Hi, Assalamualaikum. And how are you doing, everybody? Okay. Today, we are from Group 4. I am the group leader, Ahmad Siraj, and my group members are Nur Shafiq Ashraf, Shahmi Ezri, Divashini, and Tuan Nona Suha. We'll be doing the topic of reinforced earth. Okay, you want to know what reinforced earth is? You have to stick around and hear for this video. Okay, so let's go.
Assalamualaikum and hi, my name is Muhammad Shahmi Ezri. Today I would like to tell you guys about soil reinforcement. In simple terms, soil reinforcement is a technique used to improve the stiffness and strength of soil using geoengineering methods. A long time ago, natural fiber was used to reinforce the soil. This old technique did not have a high yield and required a lot of time for the soil to recover. In geotechnical engineering, soil is restored and reinforced with the distribution of minerals and soil nutrients. Soil reinforcement is necessary in lands where chances of erosion are high. It is particularly useful in areas with soft soil as it cannot provide adequate support to any construction or building. This type of soil is also highly susceptible to various environmental and natural factors such as high compressibility, poor shear strength, temperature changes and others. In soil reinforcement, different engineering techniques are used to enhance the soil strength. One product that is available is geogrids. Next one, how is soil reinforcement done? Soil reinforcement is performed by placing tensile elements in the soil to enhance its natural stability and strength. This is achieved by bringing reinforcement elements in contact with surfaces in the aggregate and subbase of soil mass. When pressure on the soil mass causes a strain on the reinforcement, it creates a tensile load which can resist soil movement and provide additional support for increased strength. This way, a soil reinforcement system is created which provides greater shear strength than the soil mass alone. Next one, challenges in soil reinforcement. Soil reinforcement plans are always customized according to the soil's texture and its load-bearing capacity. Due to a wide variety of soil and load variants, bioengineers experience a number of challenges during soil reinforcement. These include for embankment on weaker foundation. For example, for embankment on weaker foundations such as airport near sandy ground, the biggest challenge is to reinforce the soil and stabilize it. Next one, for steeping slopes. Layers of geotextiles are placed strategically on the land to steepen soil slopes. The purpose is to increase the tensile strength of the soil for minimal sliding or rotation. And lastly, for closing of soft side, geotextiles are a cost-effective method of reinforcing soft soil in areas such as lagoons, sludge ponds, and many others. Geotextiles can strengthen soft soil by providing high tensile support and anti-deformation capability to support building structures and improve the quality of soil body. Thank you.
Now I will talk about advancement. The advancement is we use geogrids. What is geogrids? Geogrids' function is to mechanically stabilize granular materials, reinforcing soil slopes and retaining walls, providing safe access over soft ground, reducing aggregate layer thickness in pavements, and increasing the ground-bearing capacity beneath roads and railways. So, geogrids were first tried in 1980 to build a temporary retaining wall supporting a railway at Newmarket Silkstone Colliery, Yorkshire. An uni-axial geogrid was used to reinforce milestone with stabilizing the embankments while Biaxial geogrid stabilized aggregate beneath. Since then, geogrids have been used on thousands of projects globally to build earth retaining structure with up to 120 years design life and to support roads, railways and traffic areas, saving significant time and money over alternative methods. Okay, so now what is advancement of geogrids? Geogrids continue to evolve with a hexagonal grid triax launched in 2007. For roads, aggregate stabilized with triax delivers high-performing pavement that are considerably thinner, last longer, use fewer materials and enable the reuse of low-quality site-worn fill, drastically reducing environmental impact. Innovative and high-performance geogrid and geotextile products offer alternative approaches to traditional method. It already have benefit thousands of projects around the world, from road, rail, and airport infrastructure to housing, commercial buildings, waste and landfill, and utilities and energy. There are three types of geogrids. The first one is uniaxial geogrid, second is biaxial geogrid, and the third one is triax geogrid.
Okay, now let's talk about reinforced earth. Reinforced earth is a material formed by combining earth and reinforcement. The reinforcement improves the earth by increasing the bearing capacity of the soil. Okay, reinforced soil is obtained by placing expandable or permanent materials such as metal strips or polymer reinforcement in the soil to obtain required properties. This will reduce the soil behavior, such as the movement of the soil. Therefore, reinforced earth is not a complex thing to achieve. The reinforcing material may include steel, concrete, glass, planks, geogrids, and much more. So there are three layers. So if we need to understand, is the first is soil, second is the skin, and third is the reinforcing material. Okay, there are many applications of reinforced earth. Okay, so now let me explain to you what are the applications. Okay, here are some applications which includes the stabilization of the soil, construction of retaining walls, bridge embankment for highways, industrial and mining structures. Okay, let's look at the first one. The first one is blast barriers. Okay, blast barriers is used for such as where you are in the mining industry, prevents outside public people from getting any disaster occurs in the mining. Second is river retaining, which means when the river water rise, there will be no flood and prevents the wall from collapsing due to high water levels. Second is rock fall protection. This is when people are building tunnels to prevent from the workers getting injured. Okay, then building of tunnels. Okay, after the safety were regarded for the rock falls, then the formation of the tunnel is also in the concept of reinforced earth, because people can use it safely nowadays. Okay, then it's used for retaining walls against the sea or the river, such as the first one. It prevents from the soil getting pulled out by the sea or the river. Then it is reinforced for bridges. Okay, prevent from the earth sucking down the bridge and making it collapse. And it's also for supporting massive construction of structures such as airports. Airports gain a lot of weight from airplanes and aircraft, so the walls need to be strong, because some airports were built by the ocean for easier takeoff. Okay, that's all from me. Now let's continue next.
Next, I'm going to present the advantages and disadvantages of reinforced earth. The first advantage is cost effective. For an example, reinforced walls are expected to cost about half of cantilever or creep wall project with the same height. Next is rapidity of construction. Because the reinforced wall uses small prefabricated components and requires no formwork. It can be readily adapted to variant of height or shape. The third one is adaptability to various slopes and soil condition. It is because the reinforced earth have high modulus reinforcement that producing composite material that can adapt to movement of the surrounding ground. And next, the fourth one is flexibility. Reinforced earth allows to withstand considerable amount and differential settlements without structural failures. And the last one is aesthetic. Reinforced earthworks create a natural and aesthetic appearance. Then, for the disadvantages of reinforced earth, first one is non-availability of suitable fill material. For example, for the reinforced wall, required granular fill. When there is lack of granular fill, the cost for importing suitable fill material may render the system uneconomical. The second one is suitable design criteria. Reinforced earth is a combination of structural engineering and geotechnics. Structural engineering take care of geotechnical parameters so that it does not cause corrosion, deterioration, and degradation. The third one is shared responsibility. The design and the construction of reinforced material, design and construction of reinforced system often requires shared responsibility between system designer, material suppliers, designers, contractors, and engineers, and also owners. Moreover, great inputs from geotechnical specialists are required by structural engineer. The last one is design and construction. A standardization of specification and contracting practices are the must for all the geotechnical projects. That's all about advantages and disadvantages of reinforced earth.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nasuha. Okay, today we will address about innovation. Okay, the innovation, the point of view is retaining wall design by using keystone or treated pine as replacement to the concrete and geogrid as the prevention from landslide. Because it was a more economical and can cut costs because a treated pine is affordable than concrete sleeper, which is a high risk of material cost in industry. As we know, Malaysia doesn't have experienced internal conflicts such as earthquake, and the measure to use the geogrid is to prevent slope and landslide.
I guess that's all from us, from Group 4. Highest and special regards to our lecturer, Dr. Chee Ming, and all of my group members who take part so much in making this assignment for this subject throughout the semester a success. I believe that's all. Thank you, and das Vidania.
Dos Vidania. That means goodbye.